Hello and welcome to part 3. Let's get going. That last video was a little longer, so it may be cut off in certain areas. So I'm going to try to do the same thing for 12 and 13, but a little quicker so the video is not as long. So once again, number 12, we have supposed researchers interested in the effect of 3 different diet and exercise management programs on reducing BMI in young adults. Assume the following table identifies a summary statistic for the 3 groups. So we have exercise program 1, exercise program 2, and our control group. Notice how the N in each group is different, right? It's not the same across the board. So we have to, take that into consideration when we're looking at things. So the first thing the problem asks us to do is calculate mean squares between, mean squares within. Once again, the mean squares between is going to equal the sum of squares between over the degrees of freedom between. Our sum of squares between is going to equal sum of k, index of 1, ni times the x bar of your group, whatever group you're looking at, 1, 2, or 3, 4, however many groups there are, minus the grand mean squared all over k minus 1. So first thing we have to know is we have to know what our average is for everything. So I'm just going to go ahead and start writing it out so you can see it. I'm not going to go getting averages and standard deviation. You should be well versed on how to find that. So the way we write this out is we're going to take 5 times our mean of group 1 minus the grand mean of 26.0438, that's 0, squared, plus 4 times the group 2 mean minus the grand mean squared, plus group 3, total number of people in that group, times their mean minus the grand mean. And actually that reminds me to bring this up. If you are using a graphing calculator or even other calculators, a lot of times you might see a button on there that has STO and an arrow, and that stands for store. So a lot of times when you're using maybe the same variable over and over again, like when you're doing standard deviation, a great way you can do it, let me write this down. So it will look like STO and then like an arrow of some kind. And that means store. And what you can do is you can write a value like 260438. So instead of typing in there every time you type that in, hit store and then save it as a value. A lot of times I save it as X. So I would put 26.0438 store as X. So then when I'm going in the calculator, all I do is I put the mean value minus X and then square it, and that gives you your whole thing. And instead of typing out, 7 different buttons every time on every equation, this is a little quicker way you can do it. Not sure exactly at what point calculators stop doing that, but I do know on graphing calculators you can. I think I have seen it on some of the other like TI 36 and maybe on the TI 30. So if you have those, these are just little shortcuts that you can use. Okay, so going back here, so once you subtract, square, and multiply out, you're going to get 27.0002 plus 1.025 plus 13.1479. When you add all those up, you'll get 41.1731. Remember, that is your sum of squares between. Now you're looking for your degrees of freedom between, which is your k minus 1. K minus 1 here is 2. So this is going to give you the mean squares between value equaling to 20.5865. So that's your mean squares between. So now we're going to do mean squares within. Mean squares within. So sum of k, I, index of 1, n of I minus 1 times the variance of I all over n minus k. Let me write that out. 5 minus 1 times 3.642. And remember, that's the variance. I'm not going to go through each standard deviation part and step. I think everyone kind of has that. Plus, these videos will be extremely long if I keep going over all those little details that we've been going over since the beginning of the year. So you'll be able to at least check your values. So if you do your standard deviation and your variance, you should get these values. If you don't, then there is potentially an adding error or some other error in there, but you can always go back and look and you'll probably find it. So when you do this, subtract out and multiply, you'll get these values, 26.762 for group 2 plus 24.468, and that's going to equal 65.805. Remember, that is your sum of squares within. And now we're looking for our degrees of freedom within. Degrees of freedom within is n minus k. So we're going to have 13. I don't have enough room to equal over here, so I'm just going to move it over here. When you do that, you're going to get a value of 5.062. So now we take both these numbers, our mean squares between over our mean squares within. And this is going to equal your f-stat. Our mean squares between was 20.5865, shown here. And this is equal to our mean squares within divided by 5.062, and you're going to get a value of 4.0668. That is equal to your f stat. Write out your null and alternative hypothesis for one-way analysis of variance. So remember, our null hypothesis is always going to state that group 1 versus group 2 is going to equal to group 3. If you have more groups, those will keep equaling each other. A statement of no difference, they're all going to equal each other. Our alternative hypothesis is going to state that mu1 is not equal mu2, and we're going to say it also doesn't equal mu3, our alternative hypothesis. Part 4 says, what is the f-crit value? So f-crit value is the value at which this group becomes significant. Is there a significant difference between the BMIs between the groups being compared? So we go to our book in the back of the book, and the back of the book is divided by our degrees of freedom in the numerator, by our degrees of freedom in our denominator. Our degrees of freedom in the numerator was 2, so we'd find degrees of freedom 2 at the top, and on the side we're going to find 13. Well, if you go to the back of the book, you'll see that it goes from 12 to 14 degrees of freedom, and we don't have a 13. So we use Price is Right rules. We go down to 12. So we go to degrees of freedom 12, then we look at our p-value column. And we go to our p-value column, we're going to be looking at 12 at 0.05. And when we go over to 2, you'll see that we have an f-critical value of 3.89. So what that's saying is that at 3.89 f-statistic with these degrees of freedom, that is when we find significance at an alpha level of 0.05. Our f-stat of 4.0668 is greater than 3.89, so we found significance at the alpha of 0.05 level. Just to move on, if you look down to the next value there, so underneath 3.89 in degrees of freedom 2, numerator degrees of freedom 12, if you go down, the next p-value is 0.025, and our value is 5.10. As you can see, our value of 4 is going to be in between these values. So you can state that it's significant at an alpha level 0.05, but not at an alpha level 0.025. And that is how we compare those values to each other. Moving on to number 13. Once again, I'm going to go just a little bit quicker through this one and kind of just give you the raw numbers here. So we have exercise program 1, exercise program 2, and exercise in the control group. And what we have here is the first number is going to equal a value of n, so 5, 4, and 7. The next value is going to give us our sum of the total in each group here. 126.5, 119.1, 202.4. Next value is going to give us our x bar of each group. 25.3, 29.775, and 28.9143. And then the next is the variance for each group, which would be 2.875, 6.255, and 7.7281. We're going to calculate our F statistic. Once again, going quickly through this, what you're going to get is for your mean squares between, that's a horrible B. Not that my handwriting's great to begin with. Apologize. Not the greatest with it. I try though. Mean squares between and mean squares within. It's going to equal 27.45196 divided by 5.8951, which is going to give you a value of 4.6567. We're going to write our null and alternative hypothesis. Once again, our null is going to be a statement of no difference. Null hypothesis is going to be our mu1 equals mu2 equals mu3. There's no difference between these groups here. That is what we're stating with our null hypothesis. And our alternative hypothesis is going to state that two of the means differ. I didn't mean to write actually two. Mu1 does not equal mu2, mu3. At least two of these means differ from each other. What is the F-crit value? So since this is the same exact problem, just different numbers, and their F-crit value is the same thing, if you go to the back of the book, you look up your degrees of freedom. Your freedom numerator, degrees of freedom your denominator. Since it's 13, we're going to go to 12, Price is Right rules. Look at our p-value of 0.05, and you're going to see that the value is 3.89. You can see that our value of 4.6567 is greater than it, so we found significance at the alpha 0.05 level. And it's less than the next one as well. All right, so that is 13 and 14 really quick. I'm going to stop here because I think I'm going to run out of time.